All right, everyone get ready because today we're going deep into the world of number sequences.
Yeah.
These are strings of numbers that...
They seem so simple at first.
Simple at first, but then you realize
Yeah.
they unlock these amazing mathematical secrets.
Absolutely. And you know what I think is really cool about these sequences is that they show these connections in math that you wouldn't expect.
Oh, yeah.
So we'll see how a really basic sequence can lead to these
Concept.
things like quadratic forms,
Okay.
which are basically like blueprints for shapes.
For shapes, okay.
Yeah, and we're going to be talking about the work of some
Cool.
really interesting mathematicians who've thought about these things.
Great. I am excited.
Yeah.
So for this deep dive, we are using a pretty awesome tool.
Yeah.
The Online Encyclopedia of Integer Sequences.
It's great.
Or OES.
Or OES.
For short.
Yeah.
Imagine, if you will, a giant library, but
Yes.
instead of books,
Right.
it's full of integer sequences.
Yeah. And each one has its own story.
Its own story.
Yep.
Yeah. And the specific sequence we're diving into is A00000021.
Okay.
This one represents the number of positive integers.
Oh, wow.
Less than or equal to
Okay.
raised to the power of n.
Okay.
They can be expressed in the form x squared
Right.
plus 12y squared.
I know that might sound
Yeah.
a little complicated.
Yeah, a mouthful for sure.
But stick with us.
Stay with us.
We're going to break it down.
We'll break it down step by step,
Yeah.
and you'll see how much depth
Yes.
is hidden in this sequence.
Yeah.
All right, so we've got nx and y in this formula.
Right.
Can we just start with an example so we
Sure,
can
absolutely.
see how it all works?
Let's look at the example they give in the OEIS entry, A46.
Okay, so in this case, n is 4.
That's right.
Oh,
so
right.
that means we're looking at 2 raised to the power of 4, which is
Okay.
16.
Okay.
And we're trying to find all the positive integers. Less than or equal to 16.
Less than or equal to 16.
That can be expressed in that form we talked about, x squared plus 12y squared.
So we just need to play around with different values of x and y.
Yeah, you got it.
Okay.
Until we find the right combinations that give us
A result
less than or equal to 16.
less than or equal to 16.
And they actually list out the numbers for us in the OEIS entry.
Oh, they do?
Yeah.
Okay, cool.
It's 1, 4, 9, 12, 13, and 16.
Okay, so 1 is just 1 squared.
Right.
4 is 2 squared.
Yeah.
9 is 3 squared.
Mm-hmm.
Okay, but where does the 12y squared part
Yeah,
come into play?
that's a good question.
Yeah.
So if you look, we've also got 12 on the list,
Right.
which is just 12 times 1 squared.
Oh, okay.
And then there's 13,
Yeah.
which is 1 squared plus 12 times 1 squared.
Okay.
And then 16 fits perfectly.
As 4 squared.
As 4 squared, exactly.
Okay, so there are 6 numbers
Right.
that fit this criteria.
Yeah.
1, 4, 9, 12, 13, and 16.
Uh-huh.
And that's why... A4
4 equals 6.
A4 equals 6, exactly.
Like a little math puzzle.
Yeah.
Trying to figure out which numbers fit.
Absolutely.
Okay, so that's cool.
Yeah.
But is there like a bigger picture here?
There is a bigger picture.
Oh, there is.
This sequence actually connects to a broader concept in number theory
Oh, wow.
called quadratic forms.
Quadratic forms.
Yeah, have you heard of those?
I mean, maybe back in like high school math class or something.
Okay, well, it's not as scary as it sounds.
Okay.
Think about quadratic forms as like mathematical blueprints for
Okay.
shapes,
Okay.
like parabolas.
Okay.
You know those curves you see?
Right, like the arc of a ball
Yeah, exactly.
or something like
Yeah,
that.
or a satellite dish, those
Yeah.
kinds of things.
Okay, I can kind of picture that.
Yeah.
So our formula, x squared plus 12y squared,
Right.
is like one specific blueprint in this whole
Exact
world of shapes.
Yeah,
Okay.
you got it.
So by exploring the sequence, we're exploring the world of
Going into the world
those
of
shapes and their properties.
Okay, that's pretty neat.
Yeah.
It's not just crunching numbers. It's like
It's like uncovering this
uncover
uncovering-
hidden geometry behind them.
Yeah.
Is that why mathematicians
It's definitely part of the appeal.
find this so fascinating?
And actually, in the OEIS entry, they mention
Aye.
a couple of mathematicians,
Okay,
like D. Shanks
okay.
and Ke Schmid,
Right.
who've explored this sequence in connection to this
Oh, wow.
theorem by Landau.
Landau's theorem.
Yeah.
That sounds
It's a bit complex,
intense.
but the basic idea is that it deals with
okay.
the distribution of prime numbers.
Prime numbers, okay.
Yeah, you know, those building blocks of all numbers.
Right, right.
Yeah.
So this sequence is like a secret code.
It's a pretty amazing connection.
Prime numbers.
Yeah. The fact that this sequence, which seems to be about counting in squares,
Yeah.
is somehow tied to
Prime numbers.
prime numbers.
That's pretty crazy.
Yeah. Suggests there's something deeper going on.
Yeah, it's going way beyond.
You know,
it's like plugging in numbers. It's like there's a whole nother
just a hidden layer
of like math order.
Yeah, and that's not all.
Oh, there's more.
Remember those mathematicians we mentioned?
Yeah.
Their work shows that this sequence has been studied pretty seriously.
Wow.
Yeah.
So every time I think I have a grasp on this, it gets deeper and deeper.
Yeah, and more intriguing.
What else is hidden in this sequence?
Well, there's another aspect we haven't even talked about.
Okay.
The connections to other sequences in the OEIS.
So there are other sequences that are related to this one.
Yeah, like a whole family of mathematically related sequences.
Wow, so it's like this web of ideas.
Exactly.
And each sequence gives you a different
perspective.
On the same underlying mathematical principle.
Exactly, yeah. Good. Neat, huh? So I'm picturing like this massive web of all these sequences.
It's a good way to think about it. And just like exploring the links between web pages can lead you down these rabbit holes.
Yeah.
Following these cross-references in the OEIS can lead to surprising connections.
So what sequences are linked to a 0000000021?
Well, there's one that I thought was interesting.
Okay.
R00000021.
Okay.
This one represents the number of ways to write a number.
Okay.
As the sum of 4 squares.
Sum of 4 squares. Okay.
Yeah.
That sounds familiar.
Yeah. It's like
from math class.
Back to high school math.
Yeah. How does that connect to our sequence?
Right. So how does that connect to x squared plus 12y squared?
Yeah.
It's a cool link.
Okay.
It takes us deeper into number theory.
Okay.
There's this theorem called Jacobi's 4-square theorem.
Okay.
Which basically gives us a way to calculate
the number of ways to express a number as a sum of 4 squares.
So how does that theorem relate to our sequence?
Well, if you look at our formula, x squared plus 12y squared, we can rewrite it as x squared plus 2 squared times 3y squared.
Okay, I see that.
Right.
It's starting to look like the sum of squares.
Yeah, exactly.
Right.
So we're kind of manipulating the formula and revealing this hidden connection.
It's like a magic trick.
Yeah.
Okay, so this connection opened up by this Jacobi's 4-square theorem.
Yeah, opens up like a whole new avenue for exploring number theory.
It's amazing how these seemingly separate concepts
I know, it's really cool.
are all intertwined like that.
Yeah, it makes you wonder.
Yeah.
What other connections are out there?
Yeah, what other hidden relationships?
Yeah.
I noticed something else in the OEIS entry.
Okay, what's that?
For A000021, the formula section.
Yeah.
It's a little dense.
It can be a bit dense.
For a non-mathematician.
But the formula is kind of like the engine that drives the sequence. It's this compact expression that captures the whole pattern and allows us to calculate any term.
Oh, wow.
Without having to do it step by step.
So it's like a shortcut.
Yeah, it's like a shortcut.
Okay.
To understand the sequence on a deeper level.
So we've got these formulas to help us understand the sequence.
Right.
But what about just like the actual values?
Yeah, what about the numbers themselves?
Yeah, so the OEIS entry gives us a list of the first few. But what happens as we go further down the line?
That's a great question.
Yeah.
As n increases, the values in the sequence grow really fast.
Okay.
It's like a rocket taking off.
Which makes sense, right? Because we're looking at larger powers of 2.
Exactly.
So there are more numbers.
More numbers to test.
Yeah. That's the formula.
Yeah. And the possibilities just explode.
Yeah.
So understanding how fast it grows and how it behaves as it goes towards infinity is something that keeps mathematicians busy.
Wow.
It gives us a glimpse into the infinite.
So even something as simple as counting numbers.
I know, it's pretty amazing.
Can lead to these unsolved mysteries.
Right. It's a reminder that even in the world of numbers, there are always new things to discover.
Okay. So we've explored the definition of A00000021. We've seen this connection to quadratic forms.
Yep.
We've learned about insights from mathematicians.
Right.
And we've even touched on prime numbers.
Yeah, it's been quite a journey.
It has been a journey.
I think there's still more to explore, though.
Really?
Especially when we think about
Okay.
Real-world applications.
Oh, yeah, I was wondering about that. Like, how can something so abstract have a practical use?
Well, you might be surprised.
Okay.
Number theory is super important.
Okay.
In lots of areas.
Like?
Computer science, cryptography, even physics. You remember those prime numbers we talked about?
Yeah.
They're key for encryption.
Oh, wow.
That protects our online transactions.
So something as abstract as prime numbers is helping to keep our digital world secure.
It's pretty amazing, right?
That's really cool.
And who knows what other applications might come out of this.
Right.
The possibilities are huge.
Yeah, it makes me want to just dive into the OEIS. And see what else is out there.
That's the spirit.
Yeah.
And maybe you'll even come across a sequence that inspires you to do your own deep dive.
I love that idea.
Yeah.
Okay, but before I go down the OEIS rabbit hole, I have to ask. We've been exploring this sequence.
Right.
In a very, like, math way.
Yeah.
But is there a way to understand it? Visually?
That's a really interesting question.
Yeah, like, could we actually see a visual representation of A00000001?
Yeah, like a geometric one, maybe?
Yeah, maybe there's some pattern that would just pop out.
Right. You know, sometimes looking at things visually can really help us understand them.
Yeah, like it's like the difference between reading a recipe and watching someone bake.
Exactly.
Okay, so how would we even begin to visualize?
Yeah, that's the fun part.
Okay.
There's no one right way to do it.
Okay.
You could represent each term in the sequence as a point on a graph.
Oh, okay.
And see what happens.
Okay.
Do you get any interesting shapes? Do you see any patterns?
Or maybe you could use colors or shapes.
Yeah, you
could represent different
properties.
Yes.
Yeah, you could make it like an art piece.
I love that.
Yeah.
Turn math into art.
Exactly. And you never know what you might find.
Right.
You might discover some connection we haven't even thought of.
So to all our listeners out there, if you're feeling inspired,
grab your pencil.
Grab your pencils, your computers.
Grab paintbrushes.
Yeah, see what you can come up with. As a visual representation.
Maybe you'll make a masterpiece.
Yeah, maybe you'll discover something amazing.
And if you do, share it with the OEIS community. Contribute to that knowledge.
And that brings us to the end of our deep dive
into the world of A000001.
We've come a long way.
We have. We started with the basic definition. Then we saw those connections to quadratic forms.
And even
prime numbers.
Prime numbers.
Real-world applications.
Yeah. It's amazing how something so simple
I know. It's really cool.
can lead to so many complex ideas.
Yeah. That's the beauty of math.
Always more to learn.
Always more to explore.
Or mystery.
So to our listeners, thanks for joining us.
We hope you've enjoyed this mathematical adventure.
Yeah, we hope you've learned something new.
Remember, the OEIS is full of mathematical treasures.
Millions of sequences.
Yeah, go explore.
Dive in and see what you can find.
And hey, maybe you'll even end up hosting your own deep dive one day.
Yeah, that would be awesome.
Okay, until next time, keep exploring.
Keep questioning.
And keep that curiosity alive.